that'll be due next time. Okay, let's get through this lesson as quick as possible. Everybody, you need to take some notes. Here's why. That worksheet is too easy. It's my secondary 3 regular worksheet, and we're going to be above that level on the test, so we're going to do quite a few examples that are not on the homework today. We still are going to have a ton of in-class time for homework. So everybody with me. So we're learning function operations, which we already know how to do all of the math behind it. It's just learning the new notation today. We're not learning any new math. So this is a notation we have seen before. So f plus g of x is literally just saying take f of x and add it to g of x. F plus g of x is just f of x plus g of x. We rewrite it like this because then we know we take function f and add it to function g. F minus g of x is f of x minus g of x. I really should add a red flag, a purple flag here because subtraction, you need to make sure you distribute your negative through to all of g of x. Then f times g of x times g of x, and then f divided by g of x. We just need to make sure when we're dealing with division, don't we have some restrictions? The denominator cannot be 0, so we have a restriction when dealing with division. So it's just a new notation. Everybody see. You can see it written either way, like this or like this. So looking at this first example, you probably don't need to write it down. Just watch this first one, super easy. It says, what's f plus g of x and f minus g, and what is the domain? So f plus g, that means take function f of x and add it to g of x. So that'd be 4x plus 7 plus the square root of x plus x. Does everybody see? Then I'll just combine like terms, so that would be 5x plus root x plus 7. Now remember, this is technically x to the first x to the 1/2 power, so we can't combine those, can we?
No.
Now with our domain on this one, because now it's asking what's the domain, it means what can you input? If I was to plug in numbers here, what can I input? Well, remember, because there's a square root, can I plug in a negative?
No.
No. Can I plug in 0 though?
Yeah.
Yeah, the square root of 0 is 0, everybody. So isn't it true that whatever's under a radical has to be greater than or equal to 0? So our domain is any x value greater than or equal to 0. Okay, so then we'll write it in interval notation. I prefer interval notation. So greater than or equal to, so that'd be a bracket 0 to infinity. That would be our domain. Does that make sense? Domain is input. That makes sense. That's all we can plug in. Okay, so f minus g, once again, subtraction is usually where people mess it up. So you have to take function f, which is 4x plus 7, subtract all of g of x, so that's root x plus x. Therefore, we got to distribute our negative through. So we have 4x plus 7 minus root x minus x. Distributing the negative is important. So then we have 3x minus root x plus 7. And won't our domain be the same thing? Yes, that's a radical. That's the problem area. Do you agree? Our restriction is x needs to be greater than or equal to 0. So 0 to infinity would be our domain.
Can we go back to get the
Watching, once again, just watching probably this one. So it says, what's f times g of x? So we're going to need parentheses with multiplication. So we have x squared minus 9 times g of x, which is x plus 3. So now we can distribute that through. So that would be x cubed plus 3x squared minus 9x minus 27. Do you agree? Now from there, that's our answer. That is f times g of x stop. Right, everybody? So we're good there. Now f divided by g. So that would be f on top, g on bottom. So my on top is my x squared minus 9. My function g on bottom is x plus 3. Now you'd say, can my answer simplify? When dealing with division, how do we simplify?
It's an addition function.
Yeah, so we can't do any dividing here, right now, but so how would we tackle simplifying this the correct way? Back to the top, back to the bottom, restrict first, then divide. So what would the top factor to be?
X plus 3x minus 3.
Okay, good. And then on bottom, we have our x plus 3. Restrict first, then divide. So isn't it true that x cannot be negative 3? Because that would make the denominator 0. So our final answer, f divided by g, is x minus 3. So you'd say my answer is x minus 3, right? And then as long as x does not equal negative 3, so then the domain is anything except negative 3. So how would we connect that through? Domain of x values. If it can be any value except negative 3, just a reminder, isn't this a whole?
Yes.
Because it divided out, didn't it? So it would connect through. You'll say, okay, from negative infinity up to negative 3, not including negative 3, union, it jumps over negative 3, and then heads off to infinity. Right? Okay. Alrighty. So what are we looking for with domain? Two things. If we have radicals, we can't have a negative thing underneath. It is okay to have a 0. So that's why our domain was always whatever's under the radical is greater than or equal to 0. So our domain on this example would be 0 to infinity. Now what about this one? What would my true statement be? X minus 4 needs to be greater than or equal to 0. Isn't that what's under the radical?
Yeah.
What's under the radical needs to be greater than or equal to 0, so you'd add 4. So x value is greater than or equal to 4. So then you'd say 4 to infinity. Are we all okay with that? The second thing we look for is if we're dealing with the division problem because the denominator cannot be 0. So let's say that this was our answer, and I said, what's the domain? You would say, okay, my two restrictions on this one are x cannot be 2, and x cannot be negative 3, correct? So let's connect this through. We can be any other x value. So that would be negative infinity up to negative 3, not including negative 3, union. Then we're going from negative 3 up to 2. Then jumping over 2 and going from 2 to infinity. That would connect all the other x values straight through. Okay. Let's look at this one here. Last thing, this is the last thing of notes you need to write down. This is different. So function composition. We just learned how to add, subtract, multiply, and divide. Now we're doing something different. It's called function composition. So writing down this part. G of f of x is equivalent, so that's like a little open circle. It is not a times sign. So G of f of x is equivalent to G of f of x. G of f of x. So whenever we see it written like this, we're going to rewrite it in this form because then it's a lot more straightforward of which function we're plugging into the other function. So this O is the word composed. So this is saying we're taking function G and we're composing it of function f. Compose means create. So we're taking function G and we're creating it out of function f. But once again, rewriting it in this form is usually best. So watch my trick to rewrite this the correct way. When people see G O f of x, they say, well, which one goes on the inside? So just always work like this. We do what I call squish backwards. So you take x and squish it back in with f. That's f of x. Squish it back in again, so squish it back into G. So you just squish it backwards and then you rewrite it. So now we know we're taking function f and we're plugging it into function G. For example, look at these two functions. Here's h of x, here's g of x. If I said to you, find g of 2, what would you do with the 2?
Plug in a 2 everywhere there's an x.
Good, plug in a 2 anywhere there's an x. It would replace it, correct? So this would be 2 times 2 plus 3. Does everybody see? Now look at what we're looking at here. So if I said find g of f of x, instead of an x, we're going to have our function f of x. Do you see? Just like the 2, it would replace it. F of x would replace that x. So let's look at this. Here's function h, here's function g. Let's rewrite this one in the correct form. X squishes back in with g, that's g of x. Squish it back in again, so that'd be h of g of x. Aren't we plugging in the inside, just like we were here? We plug in the inside? Yes, so we're going to go to function g, circle it. We're taking function g, and we're plugging it into function h, wherever there's an x. Replacing it. Do you see? Substituting it in. So instead of x, there's a 2x plus 3 squared now. So does everyone see? I just replaced it. Now look what we did. We took function h, and we composed a new function of g. We composed it with a function g. Everybody good with that? Now people ask, do I need to multiply that out? And I say, well, that's factored form. Is standard form or factored form better? Neither is better. So let's just leave it. Let's not do extra work. Does that make sense? Okay, let's do this one. Now look, this one's g o h of x. Squish x back in with h, so that's h of x. Squish it in again, so that's g of h of x. Now this time we're always substituting in what's in the parentheses. So this time I'm going to function h of x, and I'm substituting it into function g wherever there's an x. It replaces it. So now we have 2x squared plus 3. Does everybody understand? Do we have questions? Make sense? Yeah. Okay, just replaces. All right, so looking at these, I'm going to show you 2 ways to do this problem here. So it's a given function f of x is x minus 5, and given function g of x is equal to x squared. It asks us, what is GOF of negative 3? So what we can do is first find GOF of x. So let's squish it back in. So f of x, squish it back in again, g of f of x. So we would take function f of x, and substitute it into function g wherever there's an x. It replaces that x. It's not a times sign. It replaces it. So now we have an x minus 5 squared. Do we have any questions? But now notice it says GOF of negative 3. So instead of the x, we now have, instead of x, we want x to be negative 3. So we would just plug in a negative 3 now. Negative 3 minus 5 squared. So then that's negative 8 squared, which is 64. So our final answer would be 64. That's one way of doing it. The easier way is to just straightforward squish it back in as is and calculate as you go. So for example, looking at this, squish it back in with f, so that's f of negative 3. Squish it back into g, so g of f of negative 3. Now what we can do is literally just calculate from the inside out. So calculate f of negative 3. What would we do with the negative 3? Good. Plug it into function f, so we would get negative 3 minus 5, which is negative 8. So now you're literally asked to find g of negative 8. What does that mean? We take negative 8 and plug it into function g? Yes. So then that'd be negative 8 squared, which is 64. Two different ways of getting there, same answer. The second way is easier, right? Calculate from the inside out. So, what if I was to do, for example, okay, I'm going to go to this one. I'm going to make it harder though. So, with this one, I'm going to have you try it real quick, because I'm going to, on the test, put one more of this caliber. H of G of H of 2. Calculate that. H of G of H of 2. So how do you think you'd start calculating it? Yep, calculate from the inside out, go for it. Try it with your group. If you don't know how to do it, ask them for help. I've heard a few people say 260.
Yes.
Okay, good. Do we need to go over how to get that? Just calculate from the inside out. Okay. Now looking at this next one, it says find f of g of a, so that's this, f of g of a, because we squish it backwards. So then find g of a, so I'd be plugging in a for function g. So right here, that would be a minus 3, so that's f of a minus 3. And then now take function f of a minus 3, so I'd be taking a minus 3 and plugging it into function f. So then that would become a minus 3 squared. Okay, awesome. All right, so we're going to skip that one. Pretty easy. You'll get that one. Okay, what I want you to do is now we're going to just do a couple examples of more of the advanced level that we should be at before I set you free for homework. So do this one. Ready, set, go. If we don't need to go over it, we won't. But you need to be trying these. All righty. So you guys tell me the answer, not of the domain, but just of f divided by g. So the answer is x minus 1. I agree. Now, the domain in interval notation. Okay, good, because x cannot equal negative 1, right? That's why? Okay, awesome, that is correct. Okay, next advanced one. Okay, do this one, next advanced one of this level. So g divided by h. Just a reminder, what do we first look for when we factor? A greatest common factor, right? If we have 4 terms, we factor by what method? Grouping. Okay, ready, go. You were there. So the bottom factor to be x, x plus 3, and then x squared plus 3. So my restrictions are x cannot be 0 or negative 3. That would create imaginary, so no restriction there. Divides out. So 1 over x squared plus 3. Very good. And then our domain would be negative infinity up to negative 3. Union negative 3 up to 0. Union 0 to infinity. I saw a lot of good things out there. Okay, way to go. Okay, if you're working on the homework, stop again and back up here because once again, the homework's not quite to the level we need to be at this level. Okay, let's look at number 10 and 11 on the homework. This one is on the homework. This one is fine. These ones are the ones that are better. So try 10 and 11 right now, and then we'll go over them if we need to. So this would be f times g. Did you all get that? Domain. Could I input anything into this? Not quite. I couldn't plug in a negative because of that, right? So isn't our domain 0 to infinity? X values, what's under the radical is greater than or equal to 0. Do we have questions on where I'm getting at? You got to be honest and say, well, once again, where are you getting that? Or if you get it, we're good. Okay. Then let's do f divided by g. Let's see how far you went. So we have 2x, and then our g is the root x minus 1. Is that an appropriate answer?
Yes. Yes. It was radical and denominator.
So it's a not appropriate answer. It's a not good answer, right?
That's what I see.
Yeah, okay. Yeah, so it's an answer that we need to fix. Hey, how do we fix radicals that have two terms? Don't say we multiply by root x, because then we'll have a root x y to 1.
No, we'll do reciprocal. Yes.
What was it? Almost the conjugate. Okay, conjugate. If we have two terms, we multiply by the conjugate. So we just got to fix our answer to be an appropriate answer, which doesn't have a radical on the bottom. So now my answer on top would be 2x root x plus 2x. And in our denominator, we would have x minus 1. Do you see where I'm getting x minus 1? Root x times root x is root x squared, so that'd be gone. Middle terms cancel out, and negative 1 times 1 is negative 1. Okay, our domain on this one has two things to take into consideration. Isn't it true that since we have a fraction, that we have to restrict our denominator, so x can't be 1? Do you agree? But also, we have a radical, so isn't it also true to say, but x also needs to be greater than or equal to 0? So we're starting at 0 to what value? 0 to 1, so we got to jump over it, right? Union, and then from there, wouldn't it be 1 to infinity? 0 is okay, up to 1, 1's not, so we jump over the 1, and then we head on over the rest of the way. Does that make sense, everybody? Okay. Next one to do together is this one, and here's why. It's been a long, write this down, and you will be tested on it. It's been a long time since we've done this, and I bet most of us, if we don't practice it, will not be able to get it right on the test. There's probably like 3 to 5 of you that would probably get it right on the test, if that. Because it's been so long. It's been a long time. That's why we're reviewing it. Okay, so if I said to you find f divided by g of x, we know how to do that. Wouldn't that be root x divided by the square root of 4 minus x squared?
Yes.
So technically we have this, all under the same root, x over 4 minus x squared. That is the answer, which we need to come back and rationalize in a minute. But I'm just going to talk domain for a second. I'm going to leave it right here and talk domain. Now just a reminder, if we have a radical, isn't it true what's under the radical, which is this, x over 4 minus x squared, what's under the radical needs to be greater than or equal to 0. Is that our true statement?
Yes.
Yes. Now this is a rational inequality, which we tested on a couple tests ago, which was kind of harder. So let's remind ourselves how to do it. So just a reminder is, to find the domain, we're solving for x, because that is domain. We had to create a number line, and we put our critical values on our number line. Our critical values come from, obviously, the denominator, because it can't be 0, correct? Then also, because we're finding the zeros, see, or equal to 0, the zeros come from the numerator, recall. Numerators are where it crosses the x-axis from rationals. So our first critical value comes from the numerator. It's zeros, which is 0. You agree? So that's a yes, because this is or equal to 0. So this is a yes. That value is in our domain. Now our two critical values on bottom, let's rewrite this correctly. We actually have this, x over negative x squared plus 4, which we have x over negative 1, and then left is x squared minus 4. So then on top we have x, and on bottom we have negative 1, x plus 2, x minus 2. So my other two critical values come from what makes the denominator 0. So wouldn't that be negative 2 and 2? So negative 2 and 2. Now denominators are always no. It cannot be 0 on a bottom. So these little guys have no's by them. Then what we did to find the domain was we tested values so that we knew our interval answer in interval notation. So we tested a value below negative 2 and saw if it was a true statement. So watch me plug in negative 2. Negative 2 over 4 minus negative, not negative 2. We can't plug in negative 2. That's already a no.
1.
We could plug in negative 1. That would be in here. Or negative 3, okay. So negative 3, so then that's negative 3 squared. So then on top we have negative 3, and on bottom we have 4 minus 9. So isn't that negative 3 over negative 5?
Yes.
So is 3/5 greater than or equal to 0?
Yes.
Yeah, so the answer is yes here. Now, what I want you to do is test some values So pick a value. Test in here. Is it a yes or no? Is this a yes or no? Is this a yes or no?
Yeah.
You know the answer, don't you?
Yep.
Okay, good. He knows the answer already. What is it?
It's no on that next one. Yes. No.
True. It is going to bounce in this case. Yes, no, yes. And that's based on the fact that we're dealing with a quadratic inequality. So if you test values, you'll see this to come out to be true. Okay, everybody? So then from there, there's your answer. So now our domain is, all the yes and no's tell us. So it's negative infinity up to negative 2, not including negative 2, union, and then it's from 0 to 2. The yes is on the 0, so bracket 0 up to 2, no on the 2. So everybody see how to do the domain. All that work just to find the domain. Then we've got to go back to our answer right here and rationalize our denominator to get our final answer. Not for domain, but just to get your simplified answer. So now from here we would rationalize and we would multiply by the square, we'd multiply by the square root of 4 minus x squared, the square root of 4 minus x squared. We don't need the conjugate on this one, do we? Because they're not actually, that's actually just one term under the radical. I mean, it's two terms under the radical, but you get what I'm saying, hopefully. So we have the square root of x times 4 minus x squared on top, don't we? And then on bottom, what would we have? 4 minus x squared. The square root of 4 minus x squared times the square root of 4 minus x squared is the square root of 4 minus x squared squared, isn't it? So then root cancels out with power. 4 minus x squared is on bottom. So there's your answer, and there's your domain answer. Okay, so what I want you to do now is, because you're not going to just remember that thing at one time, do now g divided by f of x to make sure that if you need help, you get help. So try g divided by f of x now.
Why do you use the 4 minus x?
Great, I like your question. Let me answer that question very clearly here. I like it, actually. So, question, this is the same idea here. We know we can't do x minus 2 squared. We can't just square that, right? Aren't we looking at on bottom, or even this part right here? Isn't this, and guess what? In calculus, this is one of the most common mistakes right here, so this is a good thing to listen to. I remember making this mistake in calculus. Why is this just not 2 minus x? So let me just make sure we're good. This is 4 minus x squared raised to the 1/2 power, correct?
Yes.
It is not okay to just 1/2 power that and 1/2 power that. Agreed.
Yes.
That is breaking the most forbidden rule, so that's why. Does that make sense? Great question. Now, none of you are going to do that in calculus. This is what my students do also in calculus. Okay, ready, go. Ready, go. Do this one. G divided by f. Great question. On the interval, are they the same? Yes. I think you're right. They are, yes. So your critical values are still 0, -2, and 2. It's just, now on this one, since g is on top, these ones are yeses, right? This one's a no, because that's the denominator. And then where I'm being told that this is still a yes, no, Does that agree?
Yes.
And then you're correct. It's negative infinity up to -2, including -2, since it's a yes on this. Union, then a no on 0, so parenthesis up to 2 bracket. Okay, hopefully we're good with rational inequalities to help us find our domain. And then your answer on that one, the final one, would have been, so g was on top, so it would have been this. The square root of 4 minus x squared times by x all over x. Or x could be in front, times in front. Do we have questions? Okay. Alright, so just looking at this one right here, do FOG of x with me. Stick with me for another 5 minutes, that's all I ask. And then the rest of the time will be yours. You'll still have 40 minutes of class, so stick with me. Does anyone have an answer that they got? Negative x squared, I agree. Yeah? Okay, great. Do I need to go over that? So if we take g of x, and if we squish x back in with g, that's g of x back into f of g of x. We're plugging in g of x into function f wherever there's an x. It replaces it. So then we have the square root of 9 minus x squared minus 9. Do you guys see how that replaces? Root cancels out with power. So then we have 9 minus x squared minus 9, oh well, plus negative 9. And then do you see how our 9's cancel? Go away now. They don't cancel out, they have to be 0. Yes? So then negative x squared, so the domain is negative infinity to infinity since that's a quadratic. Alrighty. Okay, if I was to ask you to be creative, like I will on the test at one point or another, write the function h of x is equal to 1 over x minus 2 squared as the composition of two different functions. So you've got to create. So I will, like there's one almost exactly like this on the exam, that's why I'm putting it up here, is to kind of see if you guys can think creatively. There's many different ways to do this. Many correct answers. So write out, recreate this as the composition of two functions. Ready, go. So many different ways to do it. You could have gone, okay, let f of x be 1 over x, and let g of x be x minus 2 squared. Does everybody see how that would work?
Yes.
And then we'd be taking g and needing to plug it into function f to create that. So that would be g plugged into f, so that'd be like this, g into function f. Does everybody see? So then that would be fog of x. Other people did it like this. They said 1 over x squared is f, and g of x is x minus 2. And then they did the same thing. You guys see how that works too? Many correct answers here. Alrighty. Alright, so I don't think we need to go over those ones. We're probably good. Do you agree?
Yes.
Okay, I'm just making sure when I look through this. Could you be able to do the domain on this? Will you just give me this? The last one I'll make you do, but I just want to make sure you can do the domain correctly. Last one I'll make you do, then you can have the rest of the time for homework, which is too much time for homework because that's 45 minutes of homework. 37 minutes, no. Yeah, 37 minutes of homework time. What is, okay, for the domain, so that's my answer. In a second we'll rationalize. Let's just talk domain. Isn't it true that whatever is under the fraction cannot be 0? Yeah? The denominator can't be 0. So you'd say the first thing is the square root of 1 minus x cannot be 0. That's our first true statement, right? Solve for x, so we'd square both sides. 1 minus x cannot be 0. Subtract 1. X cannot be negative x cannot be negative 1, so x cannot be 1. Does everybody see? Okay, so that's one restriction. X can't be 1. Next thing is, isn't it true that whatever's under our square root, sorry, not the square root part, 1 minus x needs to be greater than?
0.
Can it be equal to?
Yes. Greater than or equal.
Okay, greater than or equal to 0. So then let's solve for x on this one. Careful here. This is where a lot of people make errors. So we'd subtract 1. And then wouldn't we divide by a negative? Yes. If you divide by negative, you need to flip it. Good. Subtract 1. So negative x is greater than or equal to negative 1. When you divide by a negative, you flip the inequality. So x value is less than or equal to 1. All right. So that's in our domain. Any x value less than or equal to 1. But then also x can't be 1. So do we need to just take off the equal sign? Yeah. Because it can't be 1. So any x value is less than 1, so our domain would be negative infinity up to 1, not including 1. There's your domain, and then you would just rationalize the denominator to get the answer for this one. All right, go ahead and start working on the homework. I need to go up.